Thermodynamics. Thermodynamics is how to predict if a chemical reaction will occur or not. It is written by using the equation delta G equals delta H minus T times delta S. So what do all these variables mean? G is called free energy of a substance, and it determines whether or not a reaction will happen spontaneously or not spontaneously. H is a variable used in enthalpy, and it shows where the heat is flowing. Is it going into the reaction, or is it leaving? And it's measured in units of kilojoules. S is a variable, and it stands for entropy, which is a measure of disorder. So how messy is this reaction? Is it organized, or is it completely unorganized? T is temperature, and we use units of Kelvin in this equation as well. Now, when we plug in these variables here and we calculate delta G, if we get a negative delta G as our answer, that means that the reaction will be spontaneous. That doesn't mean it just happens on its own. What it really means is that once the reaction starts, it keeps going until the end of the reaction. A positive delta G is a not spontaneous reaction, so that means that once you get the reaction started, you have to keep pushing it along until it finishes. It won't just keep going until the end. And if you get a delta G equal to 0, that means the reaction's at equilibrium. A negative delta H, you learned from yesterday's lesson, that means that you are dealing with heat that's floating out of the reaction or away from the reaction, and we call that exothermic. And a positive delta H, or a positive enthalpy, means that the energy is flowing into the reaction, which means it's endothermic. Now let's talk about delta S. Delta S is a term we use called entropy. And if you have a negative delta S, that means you have an organized reaction, as opposed to a positive delta S, which means you have a messy reaction. Now, the natural state of all things, of all reactions, is it usually starts out being organized and then it becomes messy. There's 4 types of reactions when dealing with these variables. If you have a negative delta H and a negative T times delta S, that means you have a favorable enthalpic change, meaning that it's exothermic, and favorable entropic change, which means that disorder is increasing as well. If you have a positive delta H and a positive T times delta S, that means you're dealing with an endothermic reaction, but you are dealing with an organized reaction. If you are dealing with a negative delta H and a positive T times delta S, that means you have an exothermic reaction, and again your reaction is more organized, where disorder decreases. And finally, if you have a positive delta H and a negative T times delta S, that means you're dealing with an endothermic reaction, where again disorder increases and you have more of a messy reaction. So the sign of delta G all depends on the magnitude and sign of delta H, delta S, and T. If we have a delta H that is positive and a delta S that is negative, then G will be positive. And that means that the reaction will be not spontaneous. We don't want non-spontaneous reactions. We want spontaneous ones. If you have a delta H that's negative and a delta S that's positive, then delta G will be negative, and this is what we're looking for. That means that the reaction will be spontaneous. Now, if you have in the case of where you have delta H and delta S that are both positive or both negative, then delta G cannot be determined because it's all dependent on the magnitude of T. Okay? If you have a big T or a small t, that will determine whether or not you have a negative or a positive delta G. Here's an example problem. So, for the reaction, NH3 plus HCl goes to NH4Cl. Calculate the delta G for the following reaction at 25 degrees Celsius. Well, you're given a negative delta H, which is negative 176 kilojoules, and a negative delta S, which is negative 0.2848 kilojoule per Kelvin. When we plug that in, and we're given a temperature at 25 degrees Celsius, when we plug that in, we get a negative value of G, which is negative 91.12 kilojoules. Is that a favorable or an unfavorable type reaction? Well, if it happens spontaneously, that's a favorable reaction. So it is a favorable reaction because it's spontaneous. And how do we know? Because we have a negative delta G.